Alright, now that we've covered errors for a bit, let's hop back onto the programming statement train and talk about one of the most important concepts in computer science, the function. Now you may not know it, but we've actually been talking about a few functions this entire series. Print statements, for loops, and even the basic math operations we've talked about are all examples of functions, which of course begs the question of what actually defines a function. Well, a function is a segment of code that can be easily run by calling the function name, and depending on the type of function, will do something in return. Functions can be called numerous times and in numerous places in your code. Essentially, they are like wrapping up a segment of code into a nice present and giving it a name, which, when called, will unwrap the present and go through the code that you had wrapped up. For example, the print statements we have been using this series allow us to print something to the console anytime we want. Those are functions. You see, we just call the print function and enter in what we want to be printed to the console into the parentheses, and the computer does it for us. Behind the scenes, there is actually even more complex code that is in charge of taking your text and translating it to the console to be printed. The developers of almost all programming languages realize that you don't want to program something that manually has to print something to the console through the use of complex programming, and so they implemented the print statement to reduce the stress and complexity of code on the user, abstracting it to the single line of code that is print. All of that code that is used to print something to the console is wrapped up like a present and given to us in the form of one line. This is actually the main theme of all functions and the backbone of any good program. Oftentimes in your program, there are going to be sections of code which are repeated and serve the same purpose, or equations which you want to allow differing inputs of. And so you can use functions in order to condense these down into singular lines of code to save both time and reduce clutter on your code. As you will see soon, functions are extremely powerful and will definitely be something you utilize all the time in your computer science journey. The print statement is just one example of functions in everyday code. There are thousands of functions that are available to you through the IDEs. However, because we won't always use all the functions that are available to you in a single program, you have to import these functions from packages found in the IDE, which is something that we'll be covering later on. Now there are four main types of functions in most programming languages, and they are separated by two defining features: whether or not they take in arguments and whether or not they return values. Let's start by separating them by whether or not they take arguments, but first we have to cover what arguments actually are. Arguments are essentially variables that we pass into the function in order to be manipulated and then either returned back to us, printed to the console, or used in another operation. Think of functions with arguments like this. If you walked up to your local Five Guys and told them that you wanted to get food without supplying a type of food, they would probably look at you confused. In order to get the food that you want, you need to tell them exactly what you want to order so that they can give it to you. In this case, getting food is the function, and what you order in terms of food is being passed in as the argument. Based on what you tell them, or the argument that you pass into the getFood function, they will do something different. You should also note that the argument can be many different things. It could be fries, burgers, sodas, really anything on the menu, and such is the case with arguments in programming. Arguments can be strings, integers, arrays, pretty much anything. As an example of a function that takes in arguments, let's look at the max function, which takes in two integers as arguments and returns the maximum number between the two. Now for this function, if you don't input two numbers or variables for it to compare, it's going to throw you an error, just like the Five Guys employee. He doesn't know what you want to eat since you didn't provide him with any arguments, and the computer doesn't know which two numbers you wanted to compare and return since you didn't provide it with two integers. Arguments are a way for programmers to have one function that can do many different things depending on whichever variables can be passed through. Arguments add variability to programming and can help diversify your code. Think of it like this. A restaurant that only allows one type of food to be made, regardless of what you order, isn't going to be very useful or diversified. But if we're able to pass in arguments and tell them which food we want, our experience can be heightened and more options can become available to us, which is exactly what happens when you start using arguments in your function. Now that we've talked about functions that take in arguments, let's move on to functions which do not, because functions can also be created and used without taking arguments in, and still be incredibly useful to the programmer. For example, let's say you are making a text-based RPG game, and one of the options you give your player is the ability to view their stats at various points throughout the game. Now every time you come upon this option, and they choose the View Stats button, you don't have to type out 6 different print statements for every statistic they may have. Your code would get cluttered and messy very quickly. Instead, what you could do is you could package the 6 different print statements in a simple function called print_stats. You don't need to pass in any arguments into the function, since the function will do the same thing no matter what the statistics on the player are. Now, every time the user wants to view their stats, you could simply call the print_stats function, and voila, the user's stats are printed for them to view. This allows you to save a lot of time writing code, but also a lot of space, which is extremely important when your programs begin getting into hundreds and thousands of lines of code and you want to easily search through it to maybe debug. Okay, now that we've separated functions into those that take arguments and those that do not, let's again split these up into those that return values and those that do not. Now the thing you have to understand is that when you're making your own functions, which is something that we'll be covering very soon, you have to choose what your function will return, if anything at all. Functions are able to return values back to the user, whether they be in the form of string variables, integer variables, or even arrays. Now the thing to note about returning variables is that calling the function alone won't do anything. You have to return the value into something or print it out. As an example, the max function we talked about previously would return an integer back to the user. But in order to do something with it, we would have to either set a new integer variable equal to the result of that max function, or we can print out the result of the function, which in this case would just print out the maximum value between the two integers. Using functions which return values don't do much on their own. You have to pair it with something in order to gain the use from it. Let's do another example. Let's say you had created a function which took in 2 string variables as arguments and combined that using that fancy string math we talked about earlier, and then returned them as a singular string. This combined string function could then be used to create new string variables, since what it returns is basically a string. The variable would simply be set to whatever is returned from this combined string function. The last type of function is one that does not return anything, and these are known as void functions. Oftentimes, these are like the print_stat functions that we created earlier, simply used to condense large amounts of print statements that appear often in your code. These cannot be set to variables, since they don't return anything, and just get the code that's within them run through. So there you have it, the 4 types of functions: ones that take in arguments and return something, ones that take in arguments and don't return something, ones that don't take in arguments but still return values, and ones that take in arguments and don't return anything. Each of these 4 types of functions are useful and unique in their own way, and you will probably find yourself using each of them through your programming journey. So get used to the different types of functions, and know how to make the most of them, as they are all extremely powerful. Finally, I'd like to talk about one of the major benefits of functions, which is that it makes it super useful to make large changes to your code without having to go through the entire program. Each function call is essentially just a copy of that function's original code, and so it's very easy to make changes to that initial function and have it translate across your entire code. Let's go back to our print_stats function and say that you wanted to go back and add in a new statistic that the player could level up and through experience in the game. Without functions, you would have to go back into your code and find every instance that you had printed out the user's stats and create another print statement to display the new statistic. However, if you had created a print_stats function like we did just a while ago, all you would need to do is find out where you define that function and add in a print statement which displays the new statistic, and you're done. Now, every place which you had previously called the print_stats function will now also print the new statistic as well. You can see just how powerful functions can be if used properly, and we haven't even scratched the surface yet.